All right, here we go. We are starting chapter 5, and let's write a couple words down. The first one is the main one that we're really going to deal with. The second one is kind of like, it's really not that super important, but the first one definitely is important. We're going to use that a lot. It's called the Circumcenter. Oops, I got to change my little writing thing up here. I always forget to do that. Okay, let's try this again. There we go. It's Circumcenter. That word circum, we had a word, we dealt with that. We had circumference, right, okay? So you're kind of dealing with a circle, and I'm going to show you, maybe I'll show you, how it has to do with a circle, because at first it doesn't look like it has anything to do with a circle at all. Okay, but we're going to talk about a circumcenter, and that's going to be the main one. We'll spend most of our time talking about that. And then if we have time, we might have to do this tomorrow, but it's a orthocenter. All right. So basically what we're doing is we're taking a triangle, excuse me, we're taking a triangle and we're going to draw some stuff within the triangle, and there's going to be a couple places that kind of look in the center of the triangle. But how do you really have a center of a triangle? You know what I mean? But we have a thing called the circumcenter that we're going to deal with. All right. Before we do that, we are going to deal with, and we'll go to that next program here in a second. I want to talk about a perpendicular bisector. I don't know if we've talked about that before, but we've talked about the word perpendicular before, and we've talked about bisector before. Perpendicular. P-E-R-P. What? Circumcenter, orthocenter, perpendicular. P-E-R-P. I know my writing's not great on this tablet thing, but P-E-R-P-E-N-D-I-C-U-L-A-R. Okay, perpendicular. And we're going to talk specifically about a perpendicular bisector. All right? So what does it mean to be perpendicular? Two lines that are perpendicular, what do they make? What do they form? Form a 90-degree angle, exactly right. Okay, what about a bisector? What if I bisected a segment? If I bisected a segment, what does the bisector do to that segment? Cuts it in half, exactly. Makes two equal parts, okay? That's what a bisector does. Everybody got that? So a perpendicular bisector, I'll just draw that on here right now, and then we'll eventually go to this other program in a second. So if this was the oops, keep doing that. Let's try this again. So here's my segment from here to here. What would this point right in the middle be? It would be the midpoint. That's right. Now, if I was going to make a perpendicular bisector, I would go through the midpoint, but what would it look like? Would it look like this? Would it look like that? No, it's a what kind of bisector? Not just any bisector, it's a perpendicular. So it should look like what? Straight up and down, exactly. Okay, or a right angle. Okay? What's a right angle? How many degrees is a right angle? 90 degrees. Okay? So that right there, this one that's up and down right there, is considered a perpendicular bisector. If this was the midpoint, how can I show? Let me put a point at the end here, point at the end here. And if I said that those two segments right there are equal to each other, this would be a perpendicular bisector. Everybody got that? Okay. Let me go to this other program. What did I do? Oh, there it is. Oh, it's going to open it up twice. That's dumb. Well, let's do this. And I have to come up on... Wait a minute. Oh, goodness gracious. Why is it doing this? Hold on. Give me a sec. Oh, I know what I got to do. I got to do that. There we go. Okay, now it's on. Now it's being recorded. It's weird. I got to make sure that these things are on and off depending on which program that I use so that people can see it. So let's go to this. All right, so here's this little program. It's just for teaching purposes. I think it's kind of cool. Instead of me just drawing lines, it does a really nice job of drawing lines and showing you specifically what half of it is and all that kind of thing. So if I was going to do a segment, it's got a little, see that little thing that says segment right there? So what I do is I click here, oops, and I click there, and it makes a segment. It's pretty cool, isn't it? All right. And I don't want that. do that. Okay, so now what I'm going to do is I want to find a perpendicular bisector. And this thing actually has a thing that says perpendicular bisector, which is kind of cool. So I'll click that, and then I believe, I haven't used this, there we go, and there it is. There's perpendicular bisector. You see that line going straight up and down? Now, it's a line, so a line keeps doing what? Keeps going and going and going. So if I made this smaller and smaller and smaller, notice, I'll never get to the ends of that. Why? Because it's a line that keeps on going and going and going. Right, okay, so that's that. So that's kind of cool. How do I know it hit it right in the middle? Well, I'm glad you asked, because let's put a point right there in the middle, okay? And if I remember how to do this, I don't use this program all that often, so if I hit distance or length and then I click this, is there glare? Is it? You gonna stay awake? All right. Is that better or not? It's probably just from the projector. Are you gonna? There's no way you guys are gonna stay awake with the lights out. Well, it was that. Let's do one. Let's see if it's any better or worse. Let's see. Is that all right? You can still see it, right? Yeah. Actually, that's not what I wanted to do right here. I thought, oh, I know what I need to do. Watch. If I hit segment, sorry, I don't want to take this, and then I go from here to here, there we go, and then I hit distance or length, and then I click on this. Let's see, where is it? Daggone it. Let's try this. Oh, I don't know. Well, anyway, stupid me. You want me help? You want to help me? How you gonna? I know. I was like, how are you gonna help me? Hold on, just a second. I just want to see. It should tell me the distance, the length of that. I don't know why it's not doing it. Yeah, it tells me the whole length from A to B, but I don't want that. I want from A to C. Thought I did that. Let's try it. Sorry about this. This other thing we're going to do is more important. Oh, there, let's see. Boom, boom. Okay. And now I click distance. Click on it. That's still not doing it. Who cares? Just take my word for it. C is in the middle. All right. C is in the middle. And this is a right angle. It doesn't really show the right angle thing, but that's all right. We're good with that. Now what I'm going to do is I'm going to put another point on that perpendicular bisector right there. Everybody see that? Now, what I want you to consider, okay, look at from A to D and from B to D. What do you think might possibly be true about AD and BD? Yeah, it sure looks like it, doesn't it? Let's see. Oh, I don't want that. Hit move. There we go. That's what I wanted to scooch it down a little bit. All right, so it looks like from A to D and A to B is the same. So let's see if I can do it this time. So if I click segment and go from A to D, there we go. And then I go from B to D, there we go. All right. And I think this is going to work. Give me a sec. Watch this. Oh, there we go. Now look, does it matter where on the perpendicular bisector that point D is A to D and B to D going to still be the same? Yeah, absolutely. Now, let me try it. Let me try it this time. It's not what I want. Actually, I could do this. Watch, I could click on this and I can actually change the color of it. Let's do that. Let's make that kind of red. And let's click on that. And let's make that red. Now we'll keep them both the same. And now what I'm going to do is I'm going to hit distance or length. Now if I click on this, yeah, there it goes. It shows me the length of that. Now I don't know if it's in inches or centimeters or whatever. It's just some arbitrary unit, all right? But it's 8.9. What do you think might be true when I click on this BD? It's probably going to be what? It's probably going to be 8.9, exactly, all right? And I think I can actually take this, if I hit the move thing. Well, I was able, there we go. I thought I was able to do that and move that right there. So now check this out. This is pretty cool. And this is going to be one of our theorems that we're learning. Okay, I'm not just doing this for fun. This is something that we're learning here. Somebody wake Trevor up, please.
Hey, Cornelius.
Okay, now take a look at this. So look at this. If I move this down closer and closer, these two lengths are still exactly the same, aren't they? All right, it doesn't matter. I could take it down here, and they're still exactly the same. If I put it right there, yeah, it's half of, right. Okay, everybody got that? Okay, yeah, it is. It's pretty cool. So, why are we doing this? Well, we have a theorem. Okay, it's the very first theorem. You have your books open? Actually, I can type this out. It's been several weeks since I've used this, and I forget how to do the typing thing. There is a thing where I can... What if I write... Where does it say? Right here? Where at? No, that's not it. Let me right-click. There is a thing. What if I double-click? No. Anyway, I'll have to work on that because we'll be using this program for a little bit, so I'll get better at it. Sorry, I'm not that good at it right now. Yeah, there's all kind. Oh, there it is. Text right there. It's way down the bottom. Okay. So here I can type it right here. Then it'll put it there, and I can move it around. So what's it say? It says a point lies on the perpendicular bisector. So a point. Let's write this down. Lies on the perpendicular bisector of a segment. Oops, let's spell segment right. Segment, if and only if. If and only if. I'll tell you what that means in a second. If and only if it is equidistant from the endpoints. If it is equidistant, which means the same distance, right? Distant from the endpoints. Now, what in the world does all that mean? Well, let's hit OK. There it is right there. See how cool that is?
It's like a math teacher's dream.
Oh, it is. It's a math teacher's dream. Actually, here's something else I can do. Let me just bear with me for a second while I play around with my new toy here. Let's go from there to there, and then let's click that, then this, and then I'm just going to get rid of that big long line by doing that. But I still have the perpendicular bisector. You see DC is the perpendicular bisector, and if I grab this, it still moves it up and down, and it takes the perpendicular bisector down there. So it looks a little bit better without that line through there. So what does that mean? A point lies on the perpendicular bisector. So which one is the perpendicular bisector? Give it to me by the letters. What's that? Lies on. Lies on the perpendicular bisector. Thank you for that. Okay, a point lies on the perpendicular bisector. So what is the perpendicular bisector, Bryce? CD or DC, either one, right? That's the perpendicular bisector. So it says a point lies on it. So D is on it. Would you agree? Okay, so a point lies on the perpendicular bisector if it is equidistant. What does that mean? Equidistant. The same what? The same distance, right? The same distance from the endpoints. Is point D the same distance from A and from B? It is, isn't it? Okay, D is 8.4 from A, and D is 8.4 from B. So basically what it's saying is this. If this point out here is the same distance from the two endpoints of this bottom segment, then it lies on the perpendicular bisector. Okay? It goes both ways. That if and only if, you could look at it like this. You could say if a point lies on the perpendicular bisector, then it is equidistant from the two endpoints. Hear what I just said? So if a point lies on the perpendicular bisector, then it's equidistant from this endpoint and this endpoint. You could go the other way. The if and only if means you could switch it around. Instead of saying if a point lies on the perpendicular bisector, what could we say? If a point is what? Look where my thing is. I'm giving you a huge hint. You could say if it's equidistant from the endpoint. So if I have a point out here, I don't know what's on the perpendicular bisector, but I do know that it's the same distance from here to here. What must be true about it? It must lie on the perpendicular bisector. All right, enough of that. Okay, so that's pretty important. Because if they didn't tell you that this was a right angle, you should be able to tell it's a right angle. Why is that? This is super important. So because if this point is the same distance from A as it is from B, then that point lies on the perpendicular bisector. Well, if it's on the perpendicular bisector, this has got to be perpendicular, which means this has to be a what? A right angle. And it's on the perpendicular bisector. So what's true about AC and BC? They got to be congruent. They got to be equal to each other. Everybody with me? So this theorem basically says if you have a point that's the same distance from the endpoints of that segment, then it lies on the perpendicular bisector, which tells you two things. It tells you that this line right here is perpendicular to this line down here. And secondly, point C must be the midpoint, which means AC and BC are equal to each other. You can see where they're going to put a lot of numbers in here, and you're going to have to figure out stuff. Would you agree? All right, so you can see what they're going to do with that. So they will do a lot of stuff with that later on. All right, enough of that. Let's go back to this. And let's scooch this out of the way. I think it's, why isn't it scooching? Hit that. There we go. All right. Now, here's another one. This is where we're going to do the circumcenter. So if you want to write circumcenter down, I'll write it right here. So circumcenter. So this is the circumcenter. Oops, cancel out of that. All right, now, bear with me on this one. This is kind of cool, though. I can take any triangle. Doesn't matter if it's a right triangle, an acute, an obtuse. I'll just do any triangle. And I'll make it with, actually I can make it, there's a triangle thing, polygon right here. So I can click that, watch, I just click one point, click another point, click another point. I don't know, let's make it down here, and then come back to the original one. And now I got a triangle, and I can move it all around, right? I could even change, right, the shape of it and all that kind of stuff. Pretty cool, huh? Excuse me. All right, so what we're going to do, we just talked about perpendicular bisector, didn't we? All right, so we talked about that first so that we could get to this thing right now. What I'm going to do is I'm going to draw the perpendicular bisector of all three sides. Okay? So let's go to this side right here. Let's draw the perpendicular bisector. I actually have a button that says what? Perpendicular bisector. Okay, so I'm going to click that, and I'm going to come over here. So what do you think it's going to look like? It's going to find the what of this side? Midpoint. The midpoint, and then it's going to make a line that is, well, it may not necessarily go to G. It's going to be in the middle, but it's going to be 90 degrees. That's right. It's going to be perpendicular. Okay? So watch. All I got to do is click on it, and boom, there it is. Okay? So I'm going to actually click the word point, put a point right there. Everybody got it? So what is this? This is perpendicular bisector of EF. H is the midpoint, and this is perpendicular, so what kind of angle is it right here? It's a right angle. Let's do it to all three of them. And you're going to see something that, to me anyway, I think is pretty cool, that's going to happen with all three of these perpendicular bisectors. So watch, if I click on this, what's it going to do? It's going to find the midpoint of this, and then it's going to make, and so the line will probably go somewhere around in here. Would you agree? Oops. I didn't hit perpendicular bisector. I got to hit that. Okay, now let's do it. Ready? Boom. There it is. So that's a perpendicular bisector. Everybody got it? Hit the middle of EG, and I tell you what, let's just put a point there. It doesn't look like it, but it's, I think it's F or I or something. Looks like an I. Yeah, HI. We got one more to do, don't we? Okay, yeah, let's do the perpendicular bisector of FG. Now, this is where I think it's kind of cool. If I do a perpendicular bisector here, what do you think might happen? Where do you think it's going to go through?
Where those intersect.
Exactly right, okay? It's going to go right through here where they intersect each other, all right? So watch, if I click here, it's going to make me a perpendicular bisector, and look what happens. It goes through, right through the other, okay? Which I think is kind of cool. It's not like they just go everywhere. They just happen, I'll put that in air quotes, they happen to go through the same point. Okay, they don't just happen. And it doesn't matter what our triangle is. So watch, if I take this and I move it around, look. See, yep, they move with each other. All right, it doesn't make any difference. Okay? Look, if I did that, they actually intersect right on the triangle. If I did that inside, if I do that, they intersect outside. Okay? Well, I'm just taking these two sides. I'm just taking these two sides and moving it. I know, because me just grabbing this point, listen. I know, that's what I'm trying to show you. Watch. Yeah, it's basically what it is, okay? And it's just moving there. And if I took E, now it'll move those two sides, right? So whatever two sides make up that vertex, and if I take this, and I move it like that, okay? All right, you with me on that? Okay, that's kind of cool, isn't it? But there's something even cooler than that, all right? So let me, I'm going to put this midpoint right there, and then I'm going to put this right here. And I believe, yeah, I think I can name this. And I'm going to name this Circumcenter. I don't think, all right, I'm going to name it Circumcenter. Create sliders. I have no idea what that means. I'll just hit OK. Well, that's not what I wanted. I thought that point right there. It's okay. Okay, anyway, we'll just call it's L. We'll use L. We'll use what they use right there. Okay? Everybody with me on that? Now, let me show you something else. So I think it's kind of cool that they intersect each other. Okay, that's kind of cool. But there's something even better than that. Watch what I'm going to do. I'm going to draw a segment from the circumcenter. Remember, point L that's the circumcenter. Okay? That point where they intersect each other, everybody hear me? That is the circumcenter. So what I'm going to do, though, is I want to show you something that's kind of interesting about the circumcenter. If I found the distance from L to each of these vertex, from the circumcenter to each vertex, let's see if it is. So watch, I'm going to make one to there. I'm going to make one from the circumcenter to F. Then I'm going to make one from the circumcenter to G. And I'll tell you what, I think, now how did I do this before? I just clicked on it, yeah, and I can change the color. So let's change it. Let's go red. Red you can see pretty easy. Well, you can move it by moving the triangle, making the triangle a different shape. Right. That's right, it wouldn't be the circumcenter. So let me make this. Okay. So I know you got a million lines in there, so I made them red to make them stand out a little bit better. Okay. So what I want to do is I want to see, is there any relationship between all those red lines? What do you think? Do you think one's bigger than the other? Do you think they're the same size? Do you think that they're all different sizes? It looks kind of like they're the same size, aren't they? So I have a thing that says distance or length, right? So I'll click on that. Let's see if it is. So if I click on that one, it's about 9.1. Take a wild guess what you think this one's going to be. It's 9.1. And then this one right here, it's 9.1. Okay, pretty cool. Yeah, I think it's already kind of cool that they intersect each other at one point. And you did too. You kind of reacted, right? But I think it's even more special, or it's you can't say more unique, but I think it's unique because all three of those are the same. Now, is it because I made that triangle like a special type of triangle? It doesn't make any difference. So watch, if I start, oops, I don't want to do that. Oh, I did want to do that. Hold on. Okay. Watch. If I move this around, look what happens to the red. They're all the same. Now, there's a different length because I changed the shape of the triangle. But those lengths are still exactly the same, aren't they? All right? Watch this. What if I made my triangle like that? So it's right on there. What kind of a triangle do you think that blue triangle is? What does that look like right here? Look at this and look at this. Looks like a right triangle to me. Okay? So now watch this. Here's something else that we know. Here's something else we know about the circumcenter. If you drew the circumcenter to a right triangle, guess where the circumcenter is going to lie? It's going to lie right on the hypotenuse of the right triangle. Very good. Everybody with me on that? So if you want to write that down, you can write that down. So the circumcenter lies on the hypotenuse of a right triangle. It lies right on the side. But what if I take that triangle and make it obtuse? So I'm going to take this one and make that bigger than 90. So I'll just kind of take that and slide that up like that. So now it's an obtuse triangle. Where does the circumcenter lie when it's an obtuse triangle? Outside the triangle. Exactly right. So the circumcenter now is outside the triangle. How do you think you can get the circumcenter inside the triangle? By making it a... We had right already. Acute, right. So now it's an acute triangle. Guess where the circumcenter is? It's inside the triangle. Does that make sense? All right. So when it's an acute, so we got three situations. We have an acute triangle, a right triangle, obtuse triangle. When it's acute, the circumcenter lies inside the triangle. When it's a right triangle, right there, where does the circumcenter lie? On the hypotenuse of the right triangle. Okay? How can you get the circumcenter to be outside the triangle? Make it obtuse. So if I make it obtuse triangle, right, because I made that angle right there bigger than 90. Here's another cool thing this does too. Watch. If I click on angle and click on this and this, look at that. It even tells you how many degrees that angle is. See, it's 112.5. Now watch, when I move this around, and see, there's 90 degrees. Well, it's almost 90. Okay? So there's 90 degrees right there, and it lies right on the hypotenuse, doesn't it? Okay, if I make it acute, see, it's less than 90. And I could do that with all three of these angles if I wanted to. I'm not going to right now, though. All right? And then it's inside the triangle. But notice, all the lengths, the distances from the circumcenter to the vertex. Everybody see it? From the circumcenter to the vertex, they're all the same length, which I think is kind of cool. That's something you're going to have to remember, though. We're going to have 4 or 5, maybe 5, I think, 5 different of these kind of things. All right? This one, how did we find the circumcenter? What did we do to the sides of the triangle to find that point right there? We found the 2 words. It was the whole beginning of this lesson. No, circ what? You're right, circum what? Well, yeah, I'm sorry. I was thinking something else. The perpendicular bisector, that's right. So how did we find the circum? And you might want to write this down, okay? How did you find the circumcenter? Find the what? Perpendicular bisectors of all 3 sides. That's how you get the circumcenter. Everybody got that? Yeah. So I'm not going to write it down just because it's too clumsy for me to write it down up here with this program. But to find the circumcenter, you find the perpendicular bisector of all 3 sides. You understand what that means, right? Okay, found the midpoint, found the perpendicular bisector, right? It's perpendicular, goes through the midpoint, and they all connect at one point. All 3 of those perpendicular bisectors connect at one point. We call that point the circumcenter. What is true about the circumcenter, though? The circumcenter, that point right here, at point L, in this case, it's equidistant from the what? What do we call those 3 points on the outside of the vertices, right? Vertex for one, vertices for plural, okay? So there's 3 of them. So the circumcenter is what? It's equidistant from the 3 vertices. Everybody got it? And that's what the theorem says. I'm not going to write it down, but it's right there on page 207. All right, if you look at page 207, it's right there, and that's basically what it says. It says the perpendicular bisectors of the sides of a triangle, it says they're concurrent. What does that mean to be concurrent? That's a word that we did earlier in the year. It means, we actually had it on the test too, on the midterm, didn't we? If 3 lines are congruent, that means they all meet at one point, right? It says, so they're concurrent, but they're concurrent at the circumcenter, which is a point that is equidistant from where? The vertices. The other points are the vertices. It's a lot of words. You're right. It is a lot of big words. Okay, but you should know what all those big words mean now. Would you agree? So the circumcenter, how do you find the circumcenter? You find the perpendicular bisector of all the sides. Everybody got that? Once you do that, then you take that circumcenter, and what's the relationship? That circumcenter is equidistant from the 3 vertices. That's right. Does it make sense? All right, it's not so bad. What do you think of that program? That's pretty cool, isn't it? Yeah, it's cool because I don't have to just draw one picture. You know, I could change this all around, make this look all kinds of crazy looking. Okay, which is pretty cool. All right, the next one is orthocenter. We don't have time for that today, but I do want you to. I'm not going to write it down because of that. So you're going to do page 209, 210. Just going to do 1 through 7. All right, I think you should be able to do all of those. So let's do 1 through 7 for homework. I'm not writing it down. I'm just saying it. So page 209, 210, 1 through 7. I think you should be able to do all of those. And we'll do some more of this tomorrow. Okay?